This is lesson 57 on division. Let's look how to do long division in binary. In decimal, we could divide 135 by 13. You remember how you do it. You see if 13 goes into 13(1), you bring down the 13, subtract 13 minus 13, you get 0, bring down the next digit 5. In here, it doesn't go in at all, so you put 0. If you have a 0, you could subtract. So the remainder is 5. So 135 divided by 13 is 10 with the remainder 5. Let's see how to do that in binary. Well, you do long division the same way. Here's the 13, 1101, and here is the binary 135. It's 10000111. So you see, how many times does 1101 go into 1? Well, no, you got to keep moving over. 1000, it doesn't go in. So finally 10000. How many times does it go in? Well, it's binary, so it can only be 0 or 1, so it goes in 1. So you bring down the 1101, you line it up here, and now you subtract. So 0 minus 1 would be 1 and a borrow. 0 minus 1 is 1 and a borrow. 0 minus 1 is 1 minus 1 is 0. 0 minus 1 minus the borrow is 0, and there's the borrow. So you end up getting a 3, and then you bring down the next 1. How many times does 1101 go into 111? Well, 0. So you multiply by 0. You subtract this to get 111. Bring down the next 1. How many times does 1101 go into here? Well, 1. 1 times 1101 is 1101. Do the subtraction. You get 1, 0. Bring down the next 1. This goes in here 0 times. So you have one more subtraction, and we're done. So sure enough, 135 in binary divided by 13 in binary is 10 in binary, with 5 as the remainder. So that's long division in binary. Now we want to see how we can try to make a circuit to do that. So here is the algorithm in a little different way. Here's the long division we just did. And what we're going to do is we're basically going to do this long division, but instead of shifting these bits right, we're going to shift the dividend here left, which is the same thing. So we start by putting the dividend, the 10000111. We're going to put that into N1 and N2. N1 is 5 bits and N2 is 0 bits. And then we're going to shift this concatenated registers, N1 and N2, left 1 bit. So we've already done that. So the 10000111 is the 10000111, and we've shifted this 0 in. So we've shifted left, and we're going to put the divisor 1101 in this D register, 01101. So there's the divisor, also 5 bits. Now, if N1 is greater than or equal to N2, then we're going to subtract D from N1 and put the result in N1. So N1 is N1 minus D because it's bigger. So this minus this is the 3. That's the 3 we had here. And anytime you do the subtraction, then we set bit N2 sub 0 to 1. So we put the 1 in there. So we've subtracted N1 minus D. That goes into N1, and we add the 1 to N0. And then we shift left again. We're going to repeat this process. So we're going to shift this left 1 bit. So this 1 goes to here, this 1 goes to here, 1, 1, 1, 1, and we shift a 0 in. So we've just shifted these two, N1 and N2, left 1 bit. D remains the same. Now we see, is this greater than or equal to this? No, it isn't. So we don't subtract now, and we just shift again. So these bits here get shifted over. That 1 goes to here, This 1 goes to here. So we've just shifted over again 1 bit. Now we check to see if n1 is greater than or equal to d. It is in this case. So we subtract this number minus this number is going to give the 2. That's the 2 we have over here, you see. And we add a 1 to n2 sub 0. So we set n2 sub 0 to 1. And then we do it again. We shift left, and we shift left 1 bit. And now this 5, again, we could put the d down here, but now since d is greater, then we don't shift, and we don't subtract, so now we're done. And sure enough, the quotient now ends up in n2. That's the quotient 10, you see, ends up here in n2, and the remainder ends up in the lower 4 bits of n1. So that's how it works. Now we can summarize it in this pseudocode here. What we do is we store the numerator in the concatenation of n1 and n2, as shown here, and we store the denominator in d. Then, since it's a 4 bits, we repeat 4 times, shift n1, n2 left 1 bit. Right? That's what we've done here. If n1 is greater than or equal to d, then n1 is n1 minus d, and n2 0 gets set to 1. And then we just repeat that 4 times, and when we're done, as we saw, the quotient ends up in n2, and the remainder ends up in n1, 3 down to 0. Okay, so that is the algorithm. Now, there's a potential problem, as you might see. Suppose that this was our 8-bit numerator, 10110101, and suppose we divide by 8. Dividing by 8 is easy because that's just shifting 3 bits to the right, so we can see the answer by inspection. If we shift this dividend here 3 bits to the right, we get 000101110, and the 3 bits that fell off, the 101, is the remainder. But look, this quotient doesn't fit in 4 bits. Well, it doesn't fit in 4 bits because before we did the shift, the high 4 bits of the numerator here was already greater than 8. This is 11, which is greater than 8. So in this case, we're going to get sort of an overflow of the quotient, since the quotient doesn't fit into 4 bits, so we won't get the correct answer. So this is a problem, and we need to figure out how to solve it. Well, here's how you solve it. You have to do this 4-bit division twice, and here's how it works. Here's what we want to do. Here's the numerator, here's the divisor, and we know what the answer is. Well, what you do is you first take a 0 numerator high. So the numerator high is 1011. So you put the 1011 here, and you put leading zeros. Well, now, since 0 is definitely less than 8, we know this will work for our 4-bit divider that we had. So if we just shift this 3 bits to the right, you can see what the answer is. This is going to be the quotient of 1. This 4-bit 1 will fit in the quotient easily. And the remainder is 011, or 3. So that's what's going to come out of here. Quotient high will be 0001, and the remainder high is 011. Now, you take the remainder high now, and you make that the high 4 bits of a new numerator. That's going to be here, remainder high concatenated with numerator low. Numerator low was the 0101. So here's our new numerator. Now we know this will work for our 4-bit division because 0011 has to be less than the 8, otherwise it wouldn't be a remainder. And so we can shift this one 3 bits to the right to see what the answer is, and you see you'll get 00000110, and the remainder will be this 101. So quotient low then is 0110, remainder low is the 101. And now you just piece the answers together. The final quotient, 8-bit quotient that we're looking for, is just quotient high that we got up here, 0001, concatenated with quotient low, 0110, and the remainder is the remainder low, 101. So here is how you can do an 8-bit divided by a 4-bit to get an 8-bit quotient and a 4-bit remainder, and this will be very useful. And in the next lesson we'll see how to implement this divider in VHDL.